Today I will review the various elasticities of demand. In particular, I will look at the price elasticity of demand, cross-price elasticity of demand, and income elasticity of demand, and we're going to calculate these from a linear demand function. So here's a linear demand function. Quantity demanded of good X, right here on the left-hand side, we got the quantity demanded of good X is going to be a function of the price of good X, P subscript X, the price of good Y, which is going to be a related good. This could be a substitute good or a complement good. And the quantity demanded of good X will also depend on consumer income, money income, M. So just to recap, the demand function here, this linear demand function, is the price of good X, the price of a related good, and as I'm showing you here, related goods could either be substitutes or complements. It's going to be dependent upon the sign of this coefficient. If C is greater than 0, then good X and good Y are going to be substitutes. If C is less than 0, a negative number, good X and good Y will be complements. M, as I said before, is money income, consumer income. And here, depending on the coefficient, the sign of the coefficient on D, we can determine whether this is a normal good or an inferior good. If D is positive, greater than 0, good X is a normal good. If D is less than 0, a negative number, good X is an inferior good. So here is the general formula set up to calculate all three elasticities of demand. So once again, we have our linear demand equation up here. We'll eventually be plugging in some values here and getting some real numbers when we solve these things. So the price elasticity of demand formula consists basically of three things. The first part here is going to be the partial derivative of the demand equation with respect to the price of good X. Once we get that value, we're going to multiply it by the price of good X divided by the quantity demanded. Simplifying here, the partial derivative of the demand equation with respect to the price of good X is just going to be this coefficient here, this parameter B. So that's the first part of the formula. And as I said before, what we're going to do then is just multiply this parameter, this coefficient, by some value for the price of good X and divide it by the quantity demanded of good X. The other elasticity formulas are defined in a similar manner, consisting again of three things. It's going to be the partial derivative of the demand equation with respect to the price of good Y. That's how we're going to start to get the cross-price elasticity of demand. We're going to take that value, we're going to multiply it by the price of good Y, and then divide it by the quantity demanded of good X. So in this setup here, the partial derivative, the first part of this formula, is just going to be the coefficient in front of the P subscript Y variable. So in this case it's C. And then we're going to multiply that by the price of good Y divided by the quantity demanded of good X. The income elasticity is defined as follows. Once again, we'll take the partial derivative of the demand equation, but this time with respect to income. After all, we want to find the income elasticity. And then once we get that result, we're going to multiply it by consumer income and divide it by the quantity demanded of good X. So in our example here, the partial derivative with respect to income will be this coefficient in front of the M variable. It's going to be D, bringing that down, multiplying it by M, and then dividing it by the quantity demanded of good X is what we need to do to solve for the income elasticity of demand. Okay, moving on. So let's do this with some real values. It's probably the easiest way to see this. So let's say that our demand equation is given as follows. We're going to let A equal 94. Okay, so I plug in some value for A. Let's say it's 94 minus 2 times the price of good X. So we're letting B in this example equal minus 2. This is going to be then plus 0.2 times the price of good Y. So we're letting C in this example equal 0.2. And then plus 0.4 times income. In this example, then D is 0.4. So you might be given on a test or an exam or a homework set a linear demand equation, maybe in the format like this. And then you'll also usually be given the values of the specific prices, the price of good X, the price of good Y, and consumer income. So let's say that the price of good X is $8, the price of good Y is $10, and consumer income is $50. So those values again will usually be given to you. So our first step in this is to just plug all of these values that you were given into our linear demand equation and solve for Q. So if PX is $8, we're going to plug in 8 right here for the PX term, so it's minus 2 times 8 plus 0.2 times the price of good Y. Price of good Y is $10, and so on. So after making all our substitutions, we find that consumers would buy 100 units at these given values in the marketplace. What we're going to do then is, with all our elasticity formulas, anywhere we see a Q, we're going to plug in 100. So going back to the previous page, all of these values right here are going to be 100. Okay, in all of our 3 elasticity formulas. Okay, moving on. Let's now go ahead and calculate these elasticities. So let's start with the price elasticity of demand. The partial derivative of the demand equation with respect to the price of good X is minus 2. That is just our B term, the coefficient in front of the price of good X. Then we're going to multiply this B term, this minus 2, times the price of good X, which we're told is $8. And then we're going to divide it by the quantity demanded of good X, which we just solved in the previous slide. We found that the quantity demanded of good X is 100. So we get minus 16 over 100, or minus 0.16. Moving on, the cross-price elasticity of demand. Once again, we're taking the partial derivative. Okay, even if you don't know how to take partial derivatives, just remember that you're just going to pull off or pick off the coefficient in front of the price of good Y. So it's just 0.2. Plugging that in here, and then multiplying it by the price of good Y, which we said was $10, and once again dividing it by 100. So in this case we get 2 divided by 100, or 0.02. And finally, the income elasticity of demand. We get the coefficient on the income variable from the previous slide. That coefficient is 0.4. Plugging that into our formula, multiplying it by consumer income, which we were told was $50, dividing it by 100, we get 20 over 100, or 0.2. And that's how you solve the various elasticities of demand. I hope you found this video beneficial.